If you're one of the millions of people today who drive a car, you probably take it for granted that as long as your tank is full, when you hit the gas pedal, your car goes forward. But have you ever actually wondered what causes your car to go? Hi, my name is Elizabeth Konopacki, and in today's Science Short, we're going to learn about the internal combustion engine and the Otto cycle. Let's go! The most common form of engine found in cars today uses a four-stroke cycle to convert gasoline into kinetic motion. This cycle was invented by Nicholas Otto in 1867 in Germany, which was important because it was the first viable alternative to steam energy. This picture shows a typical combustion engine, but the work that actually moves the car forward occurs in the cylinders. This diagram shows the four strokes of a piston that occur in one of the cylinders, and the ideal Otto cycle has four stages that correspond to the same strokes. In order to start the process, the intake stroke allows an air-gas mixture to enter the combustion chamber of the cylinder. Then, the compression stroke takes this mixture and does work to compress it without heat transfer to other parts of the engine. Next, heat is added to the chamber by means of a spark plug, and although no work is done, pressure and temperature of the mixture rises rapidly. Then, this buildup of pressure causes the gas to expand, again without heat transfer, and do work on the piston to move it out of the way. Finally, heat is removed from the system in the exhaust stroke, as the leftover hot gas is replaced with cooler gas through the exhaust valve. The car moves forward because kinetic energy from the moving piston is transferred to a common crankshaft that then turns the wheels. I should note that I've described an ideal cycle, meaning no energy is wasted. However, when you actually drive your car, there are losses due to friction and other engine support systems. These are accounted for in the calculation of efficiency. Efficiency is defined as the net work of the system over the investment you put into the system. In our case, we use the first law of thermodynamics to define the net work as the change in heat. Meanwhile, the investment into the system is simply the heat added to the combustion chamber via the spark plug. It is growing increasingly important to improve the efficiency of our engines in order to conserve our natural resources. The gasoline necessary to make our cars function is in limited supply, so we must use it as wisely as possible while coming up with a new solution, just as Nicholas Otto was able to innovate the combustion engine when steam was no longer a practical form of energy. Thank you for joining me in today's Science Short. My name is Elizabeth Konopacki, and as we say at Johns Hopkins, I encourage you to embrace your S and study science.